Hi, this is Nirmal from the Electro Store. Today we are going to see an instrument. The name is called sample holder for conductivity measurement with environmental control setup. And this system has a software which can be control the temperature, can also the humidity, and all this data can be logged in. So we're going to see this application and what are the things it can do and the sample it can measure, especially the napion and the pellet. We are going to use this setup to measure a conductivity of that simple behavior. So yeah.
So now we're going to see the sample loading thing, and here all these cables things. Let me explain from the uh, temperature cable. This is a K-type one, and this cable is used to connect the humidity sensor to the instrument, and this is a stand which is used to take this top side chamber, and there is a delicate pins are there, and this is used to keep it safely. And this is a chamber, and this is the cell cable which is to the chamber to the measuring instrument. Yeah, now we're going to see the sample loading into this sample loader which is inside, and this is the control chamber. So now we're going to remove this chamber and take out the sample holder, and this setup is called as in-plane measurement. We also have through plane, and it will be labeled as in-plane and through plane. So first we need to unscrew. So once you've taken this top side of the chamber, we have to keep it in this stand, because of the pins are so delicate. We have to keep it safely. So you can use this stand, and so now you can see this sample holder which is inside, and this one is a in-plane measurement. So you can see the contact disc is in the bottom, and the upper portion is available to pass the gas inside. So to load the sample, I'm going to take a Nafion 117, and I'm going to activate it by using a DI water. So this sample now I can load into this chamber. So you can resize the sample or cut the sample as per your wish. So this sample is 1 centimeter square. As you can see, just have to gently tighten it, and once you feel this fitting is fine, just try to screw it, and so once you feel that it's okay, you can put back inside. And there is a direction that how you're going to insert into this chamber. You have to rotate, and it will just lock at one position. There is no way that it will move. Decide that you need to insert the top chamber. So this chamber has the direction, as you can see the bottom is written the same way as the bottom here. You just have to place it, and now tighten the screws. Now we successfully loaded the sample inside this chamber. So now let me start connecting this cable connections. So this is a temperature chamber. We have to place it inside, and this is going right near to the sample. So whatever the temperature you're measuring, sample temperature you're measuring is right above the sample. And this is a cable. We made a special humidity sensing sensor, and this cable is connected to the sensor, and the other side will go to the system. So now the cell cable. So the cell cable is connected, the S minus is connected to the auxiliary or the counter electrode of the potentiostat, and the B minus goes to the reference electrode or the reference cable, sorry. And this S plus, the S plus will go to the working side, and the V plus goes to the working sense, or in some instruments called as a reference to also. So these four cables is connected to the potentiostat, and now we can place this chamber on top of the heating system, a temperature control system.
Now let us see the instrument operation. I'm going to switch on the instrument from the back side of switch, and for the emergency switch we need to turn on. It's for the transportation purpose we kept the switch, and you can see the blue light. It's an indication that the instrument is ready, and then it's a touch switch. By touching it you can turn on the instrument, make it ready for the temperature, and this switch is in off condition. This is manually, you can switch off the heater. The power line to the heater will not go until you turn on the switch. Now seeing the chamber side, you can see from the top angle, this chamber has been designed that you can pass a gas, and for the special request we added one humidity sensor. And you can see this is a 4 probe connections, all the cables you can see, and you can see the gas in, gas out, and this is where the temperature probe goes inside. And this chamber is a very special design. This temperature sensor going right over at near to the sample, and any temperature when you're measuring, it's called as sample temperatures, it's just right near to the sample, so you will get it so that your measurement will be more accurate with the temperature. Coming to the instrument side, this instrument is called 𝐒𝐨𝐿. It's from France, and we're going to use this instrument to measure the conductivity of the sample which we loaded here. And the sample right now in this sample holder is Nafion 117, and we're going to vary the temperature, and we're going to perform a conductivity measurement like a Nyquist technique with a different temperature, and we see the result. There are 3 columns. First column is for the compound connection communication settings. Second column is for the input values. You can program up to 10 steps with the soak time, and you can control the unit duration. And this is for the location, data logging locations, and here you can enter the sample name and the comments information about the sample. This is for recording. The third category is for the data graph. Here you can see the set temperature, sample temperature along with the humidity value, and in the status you can view all the important parameter status right over here. So it will show you the heating status, duration, and the step which is running, sample temperature, set temperature in a Fahrenheit, also the humidity value. So we're going to set a temperature, maybe a 3 step, starting with 35, and maybe for 2 minutes, and the second temperature I'm going to give us 45, and the third one is 55. So I'm going to run this for every 2 minutes, and as we know, soak time is nothing but once after reaching the PID value of the set point, it will execute the duration of 2 minutes only after reaching this temperature 35 and 45, 55. So we are maintaining this temperature for 2 minutes, so that is called a soak time. So now we're going to give an information. The sample name is Nafion, and its number is 117, and the Nafion (117) with active DA water. So my data interval is for every 1 second. So I'm going to start this experiment, and this data will be saved as a test by automatically. So now we configure all the settings in the software. So to turn on the heater manually, we need to switch on this one. The PID might be on, but the heater will not be on until you turn the switch in the up direction. I will started the temperature measurement, and you can see this just an animation. So now my duration started, heating process started. So it's running on the first step, and here the LED indications which will tell you like which step is running.